the second lesson is over inverse functions. So, I mean, if you guys just think about inverses are the operations that undo each other. So, for instance, if you guys see that something's been added, we'll subtract it to undo it. If it's been multiplied, we'll divide and whatnot. So, what we're going to do is I'm going to give you a function and we're going to find its inverse. So, anything in the original function should not still be there at the end. Like if you guys see multiplication and addition in the original, we should see division and subtraction in the final answer, okay? So here are your steps. Step 1, wherever we see that f of x in the function, we're going to replace it with the letter y. Okay, so step 1 is super simple. We're just replacing f of x with y. And then step 2, we're going to trade the place of the x and the y. And that's it. We're just going to switch the 2 letters, but leave everything else the same. And then step 3, we're going to solve for y. Okay? All right, take a look down here at the bottom. Make sure you guys do this with me so that you understand how to do it. Okay, so here's the original function. And it says they want us to find, now look, here's the notation for an inverse function. So you know earlier all of our functions looked like this. We used f of x. When you find its inverse, you write it as f of x, but you're going to put a little exponent after that f. You're going to put the exponent of -1. And all that -1 means is the inverse. Okay, so it's not really an exponent. It's not like they're not telling you to take it to the -1st power. They're just saying the inverse of f of x. Okay, so here's the original. Step 1, wherever you see the function notation, replace it with the letter y. Okay, so make sure you guys do that on your paper. We'd have y equals -5x minus 4. So that was step 1. Step 2, it says flip, but really all they're telling you to do is trade the x and the y. So instead of y equals, I'll have x equals. And then instead of -5x, it's going to be -5y, and then keep the -4. First 2 steps, I should never hear any of you say, I can't do them. Because the first 2 steps, you are putting in the y, and then you're trading the x and the y, okay? Now, the last step or 2 or 3 is doing whatever it takes to get this letter by itself. So we need the y by itself. So what number can I go ahead and move from this side?
4.
Okay, so if that says -4, we should all be adding 4 to both sides of the equation. Okay, now on the left side right here, can you actually combine x and 4?
No.
No, so we're just going to write x plus 4 equals, and then on the right side we just have -5y. And then if that -5 is attached to the y, they have multiplied, so what are we going to do? What's the inverse of multiplication?
Divide.
Okay, so divide this side by -5 and divide this side by -5. Okay, now look up at the board. Is y now by itself?
Yeah.
Okay, so look, this right here is our final answer. However, when we write it as the inverse, you don't want to put y equals. We want to use that inverse notation. So you're going to write f of x, and then don't forget to put the little -1 there, equals, and then just copy this back down. X plus 4 divided by -5. And that is it. For that one anyway. You know, obviously we're going to have some that have more steps than that, but overall, that's essentially what you're doing every single time. You're just undoing whatever was in the original function. screwed up. Oh. Let me turn that volume down. Okay. Is everybody good with that example?
Yeah.
Okay, turn the page. Okay. Okay, for this example, they've given us, like, here's the original function. Okay, so first thing I want you guys to do is take f of x out and put y in its place. Okay, that's step one. Step two, what do I do?
Flip X and Y.
Okay, so we're going to put the x here, and we're going to put the y over here. But all the numbers stay right where they were. You're not changing any of that. Okay, so now we need to solve for y. So look up here, please. We've got a 5, a 15, and a 7. Which of those numbers do I have to move first? I mean, I can't subtract 15 because there's still a denominator.
Subtract 5.
Not yet. And actually, that's multiplication, so we won't subtract it. What number has to go?
7.
Yeah, so if they've divided by 7, we...
Multiply.
Okay, so we're going to multiply both sides by 7. And when you multiply the left side by 7, you just have 7x. So 7x equals... Now look at the right side. This 7 here, you might want to watch. This 7 cancels out the denominator. So on the right side, you just have 5y plus 15. Okay, then what number can I move?
15.
Subtract 15. So on the left, we have 7x minus 15 equals, and on the right, we have 5y. One more step to go.
Divide by 5.
Divide both sides by the 5. And before you do anything else, as soon as you get to this point where you see the y is now by itself, this right here is our final answer. But when we write it, we have to write it using our inverse notation. So I'm going to go back to putting f of x with the -1 there equals 7x minus 15 divided by 5. And like I mentioned before, if you guys just look at the original and you compare it to what we ended with, look at my original. I had x times 5 plus 15 divided by 7. So in my final answer, instead of dividing by 7, there's a times 7. Instead of adding 15, there's a minus 15. And instead of times 5, there's a divided by 5. So if you compare your answer to the original, it should be the complete opposite as far as the operations go. And then while we're waiting, if you guys want to go ahead and take a look at the one at the bottom. Go ahead and get it started for me. So the one at the bottom, even though it says g of x, it still means the same thing as f of x. So you're still going to put a y in where the g of x is, and then you're still going to trade the x and y. Okay, so I don't know how much of that one you guys have already gotten through, but I would have put my y here. And then I would trade the x and the y. So I'd put x here and then a y over here. Okay, so now it's time to start thinking about, okay, how am I going to get that y by itself? What number can I move? Anybody?
Oh, the y or the minus or the 5. You don't times both of them by 5?
Not yet. Only if, okay, so you know on that one up top, you know how like the whole thing was over 7? This one, the fraction is separate. So I can actually move that -2 first.
Yeah. So divide by
Well, not add a negative, but add a positive, right? That's what would cancel out.
Yeah.
We're going to add 2 to both sides. So on the left-hand side, x plus 2, then equals, and then on the right side, we have 1/5 y. Okay, so then, now it looks like the only thing I need to get rid of is that 5 that's on the bottom. So if you have a denominator, how do we get rid of that divided by 5?
multiply the 5.
We're going to multiply by 5 over here because then this 5 cancels that 5. But then we also have to multiply this entire side by 5. Not just the x and not just the 2. You've got to multiply the whole expression by 5. Okay, so when we do that, if you distribute, we end up with 5x plus 10 equals, now look, on this side, there's a 1 up top, so isn't there just a 1y left? Now if this was a 2 or a 3, it would be like 2y, 3y, and then we would have to divide by that number still. But since it's 1y, do I have to divide by 1? No, we don't ever have to divide by 1, so isn't that just our final answer? Okay, the only thing we need to do is write it in the inverse function notation. So make sure, sorry, this was g. Don't forget it was a g, not an f. So g of x, don't forget your -1 in between them, equals 5x plus 10. Now, if any of you actually wrote divided by 1 underneath it, I mean, it would still be right. You just don't have to. Okay, now, most of the time, these are not the type you're going to be tested on because they all just involve addition, subtraction, multiplication, and division. Most of the time, the ones that you are going to be tested on are the ones where, look up here, there's an exponent, or if you look at the back, see how there's a radical here? There's a root. Those are the type that you're typically tested on in this class, but I wanted to make sure you guys understood how to do the basic ones before I showed you these. Fine. Okay. All right, so let's go ahead and get this started. We're looking for the inverse of h of x. So again, put the letter y here. Copy everything else down as is. Then go ahead and trade the two letters. So it'd be x equals y plus 6 to the third minus 2. Okay, what number can I go ahead and start moving?
The 6.
Not yet. That's in parentheses. I can go ahead and move the minus 2 by doing what?
Adding 2.
Okay, let's go ahead and add 2 to both sides. So I have x plus 2 equals, and then I have the y plus 6 to the third. Okay. I need you guys to think for a second. I want you to look up here. I want you just to talk this through with me. If you guys in the past, like on our do now today, if you had something that looked like this, if they told you that something squared was 4, how did we undo a square?
Divide.
What did we do? We took the, what's the opposite of squaring something?
Square root.
The square root. So you guys would do this, right?
Yeah.
Roots, so roots cancel out exponents, okay? So just because this isn't a 2, it's still an exponent, right?
Mm-hmm.
So if I want to get rid of that exponent, because right now I can't move this 6 because it still has that exponent attached. I have to get rid of that exponent before I can move, like before I can subtract 6. So I'm going to take the root, but it's not the square root. It would have to be the cubed root. So to show that, you guys just put a little 3 there. When you guys have the square root, you know there's never a number right here.
Yeah.
But you're supposed to know that it's a 2 because you're taking the square root. They just don't ever show the 2. Any other root you'd have to show. And if I take the cubed root on the right, don't I have to do that over here on the left? Yeah, we're just going to take the cubed root of x plus 2. Now, do we actually, like, can we actually take the cubed root of x plus 2? Well, no. We just leave it written as the cubed root of x plus 2. But then on the right side, this root cancels out that exponent. If they cancel each other out, what's left?
X plus 2. Or y.
Y plus
2. 6.
6. Y plus 6. The root cancels out the exponent, leaving just that expression. Now can I get rid of the 6?
Mm-hmm.
Yes, now we can go ahead and subtract 6. Will that 6 pair up with the 2? No, because the 2 is under a radical. It's under a root. So instead, we're just going to write all this stuff we're just going to write sideways. We're going to put cubed root of x plus 2. Then you'll have a minus 6 after it. That minus 6 should not be under the root. Equals, now isn't it just y?
Mm-hmm.
So instead of putting y, can't I just go ahead and put the inverse notation? Which would be h of x with the negative 1. So the most important thing about these is just roots and exponents are inverses of each other. So if you see the fifth power, you would take the fifth root. If you see the third power, you would take the third root. Whatever the power is, that's the root you're taking. Okay, so down at the bottom, it's the same, it's a very similar problem. And look down here, you guys see this? Something to keep in mind. To undo powers, take the same root, and to undo roots, raise to the same power. So those are the things to keep in mind. Those are inverses of each other. Okay, so let's get this started. Put a y here. And then we trade the two letters, right? Step 1 is put y in. Step 2, trade only the two letters. Okay, so then what number can I go ahead and move?
The negative 3.
Yep, so how would I move a negative 3?
Add 3.
I'd add 3. So the left side is just x plus 3, right? And then the right side, this just comes down. So y minus 2 squared. Okay, so then how do you undo the squared? Take the square root. Okay, so watch. You guys would take the square root on the right, which means you have to take the square root on the left. Now, we don't know what the square root of x plus 3 is. Like, we can't simplify that, so you just leave it as is. It'd be the square root of x plus 3 equals, and then on the right side, again, look, the root cancels the power. So you're just left with y minus 2. You're just left with that expression that was in parentheses. And it doesn't need to be in parentheses anymore because it doesn't have a power attached to it. Okay, so then how would I get rid of the minus 2? Add 2. And that is not going to pair up with anything. You can't pair that up with the 3 because the 3 is under a radical. Square root of x plus 3 under the radical, and then you'd have a plus 2 outside the radical. So now y is by itself, yes? So let's put the function notation at the end. So it was f of x, so now it would be f of x with the inverse notation. And that one's done. Everybody got that written down? Everybody caught up? Yeah? Okay. Flip it over to the back. We've got one more, and then You guys will have a little bit to practice.
You already got the answer key, man?
Okay, so now looking at this, there's a root. So just thinking ahead, okay, listen to me. If there is a fifth root, shouldn't we end with like something to the fifth power?
Yeah.
And then if there's a +1, shouldn't we have a -1 somewhere? And if there's a -2, shouldn't we have a +2 somewhere? These are the things, like I like to think about this stuff before I even get the problem started, because I already know the types of operations I should see at the end of the problem, and if I don't end up with one of those, then I've done something wrong. Okay, so let's just start working through this. First, put the letter Y in. Keep everything else the same. And then after you put in the letter Y, trade your two letters. So X equals the fifth root of Y plus 1 minus 2. And make sure that minus 2 is outside the radical. Okay, can I move the minus 2 right now? Yes. I could not move the +1 because it is under a root. So I can't move that one yet. But I can go ahead and move the -2 by adding it. So on the left-hand side, we have x plus 2. And then the rest of this stuff just comes down. Equals the fifth root of y plus 1. Okay, so now, how do I get rid of a root so I can get rid of that +1? What's the opposite of the root? Opposite of the root is the exponent or power. Okay, so watch. This is how you guys would show it. To cancel this out, you'd put parentheses around it and raise it to the fifth. And if I do that on the right, I'm going to come over here to the left side. I'm going to put parentheses around that expression and raise it to the fifth. Now, I would never ask you guys to figure out what this is. Like, you're going to just leave it as x plus 2 to the fifth power. But on the right side, the fifth power cancels out the fifth root. So what's left? This cancels this.
Y plus 1.
So it's just y plus 1. Last step. What do I get rid of?
The exponent. The number.
We're solving for y.
So -1.
Subtract 1 from both sides. That 1 is not going to pair up with the 2 because the 2 is in parentheses. So you just copy this stuff down sideways. X plus 2 to the fifth power minus 1 equals, and now y is by itself, so go back to your inverse notation. Put f of x, and then make sure you write that -1 in between them as the inverse. And that's it. That's the end of your notes. Like I mentioned before, I'm going to give you a practice page so you can practice some of each type. And then that's the last thing we're doing today.